Hello, anatomy students. I thought this would be a good time to go through the blood type worksheet that I sent you last night. I want to go ahead and do the first three problems on the front, and so your assignment then will be then to finish up with the back side. So I'm going to go ahead, we'll go through the first one together, then we'll go ahead and we'll practice again doing Punnett squares. And so just a little bit of review. There are some exceptions to Mendel's rules of inheritance, and so an exception to the rule is this idea of multiple alleles. And so when Mendel first did his pea breeding experiments, he only noted that there were two alleles for each type of gene. So for example, the pea plants were either tall, or they were short, or they had rounded seeds, or if they had wrinkled seeds, or if they were green seeds, or yellow seeds, or so on. However, we now know that there are some exceptions to this rule, and so one of these exceptions is the case called multiple alleles. And so this is the situation in where you have more than two alleles. And so a good example of this is blood type. And so remember, as we talked about yesterday, we have blood type A, blood type B, blood type AB, and blood type O. And so we do have to see that there are three alleles in this case. So we have A, we have B, and we have O. And so we'll go through the first few problems together. And so let's look first at number one. Notice that we have a table that shows the blood type, the genotype, who can donate the blood to, and who can receive the blood from. And so if we look at the top part of our sheet, we will notice that we have, for example, O, blood type. Its genotype is little I. It can donate blood to any blood type, so this is why this is referred to as the universal donor. However, people of blood type O can only receive blood from another O individual. The case for AB, we're going to use I capital A, I capital B, and so because both of these alleles are dominant, this is also referred to as co-dominance. And so another exception to Mendel's rules of inheritance. And so we can see that people who are blood type O or AB can be donating their blood to these people, and so they can also then receive blood types from anybody, so people are going to be the universal receiver. And so then we also have the situation for A and B. And so for A and B, we can use I capital A for the genotype, or I capital A little I. And so the first case, it's homozygous for A. The second case, it is heterozygous. And so remember, homozygous means that there is two copies of the same allele. Heterozygous means they have a copy of each allele. And so the same thing can be said for B. All right, and so let us go ahead then and look at the first problem. It says to write the genotype for each person based on the description. And so for part A, we see that they're looking for someone who is homozygous for the B allele. And so remember, homozygous again means that they have two of the same alleles. And so remember, we're going to be using an I and a capital B. And so we will then have this as our answer. So we're going to have I capital B, I capital B. I apologize for the board. I know that the lights are making it a little hard to see. I will show you the answers then at the end of this video. So the first part here is IB. The second one is looking for an individual who is heterozygous for the A allele. So remember, heterozygous means they have a copy of the A allele and a copy of the O allele. And the O allele, remember, is just the lowercase I. And so for part B, the answer for this is I capital A little I. All right, moving along, the next type they're looking for is type O. And so type O is going to be symbolized by using two lowercase i's. And so for part C, the answer is lowercase I, lowercase I. All right, next we're looking for type A and had a type O parent. And so again, this is going to be an individual that has both alleles. So one is going to be for A, one is going to be for O. And so we're going to have I capital A little I. All right. Next, we're going to look at somebody who is type AB blood. And so somebody who has type AB is going to have an A allele and also a B allele. And so we can symbolize that using I capital A, I capital B. All right, part F, blood can be donated to anybody. And so remember, that is somebody who has type O. So again, type O is going to be little I, little I. And finally, part G, can only get blood from a type O donor, would also be someone of type O blood type. And so again, this is going to be little I, little I. And so if you were to look at the answers for number 1, I'll pull it closer. And so for number 1, part A is I to the B, I to the B. Part B is I to the A, little I. C is little I, D is I to the A, little I. E is I to the A, I to the B. F is little I, and G is little I. So those are the answers for number 1. All right, now that we have that done, we're going to go ahead and do a couple Punnett squares. Remember that a Punnett square is used to show the different possibilities of offspring from 2 parents. And so we're going to go ahead and take some blood testing and seeing what's going to be going on here. All right, and so combine with me, this is a little bit older sheet, and so Brangelina is really not in the media anymore, but this was the example that they used a few years ago. It says for number 2, pretend that Brad Pitt is homozygous for the type B allele and Angelina Jolie is type O. And so the question is, what are the possible blood types of their baby? And so what we have, I'm going to go ahead and use the traditional symbols for male and female. The symbol for male is a circle with an arrow pointing up and to the right. The female symbol is the circle with the cross coming down, and so this is where you would typically see in the textbooks or elsewhere. And so Brad Pitt, we're told, is homozygous for type B allele, and so his genotype is going to be I to the capital B, I to the capital B. So I'm going to go ahead and put that here for him. And then we're told that Angelina Jolie is type O, and as you remember, type O is going to be little I, little I. All right, all we need to do now is go ahead and cross the boxes together, and so just as we did back in biology, and we're going to go ahead and see what the outcome is. And so typically you put the dominant allele first, and so in this case, we're going to have I to the big B, little 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 I. All right. Notice that in this particular situation, there's a 100% chance that the offspring is going to be type B heterozygous. And so it's going to be 100% heterozygous for the B allele. So this baby will always have type B blood, and therefore we can see that from the Punnett square. And so let me go ahead then and show you a little closer to what this is. And so the answer for B is for number 2, as we can see there. And so by doing the Punnett square, we can see that 100% of the children that they would have would be type B heterozygous. All right. We'll go ahead then and do one more example. And so the other example on the front of the page, it says to draw a Punnett square showing all the possible blood types for the offspring produced by a type O mother and a type AB father. So again, remember that the arrow here is symbolizing for male, the father. The cross here is symbolizing female. So we're going to go ahead and put the father's genotype down. Notice that he is type AB, and so we're going to use an I to the capital A and an I to the capital B. So we'll go ahead and put that in here. And we're also told that the mother is type O. So again, we're going to use 2 lowercase i's to symbolize that. All right, now what we have to do, we're just going to go ahead and do the crosses. And so we're going to cross these together, and we're going to see what the possible offspring of these 2 parents would be. And so for the first one, for example, we're going to have an I capital A and a lowercase I. So we're going to go ahead and draw that here. At the top right, we will also see, again, an I capital A combined with a little I. Down here at the bottom, we have I to the B to the little I. And then the fourth possibility, I to the B to the little I. All right, and so what we can say then, if we notice, we have 2 out of the 4 individuals that will be type A heterozygous, and 2 out of 4 which will be heterozygous for type B. And so that means that if we convert those to percents, those would be 50 and 50%. And so 50% heterozygous for type A and 50% heterozygous for type B. All right, so notice in this particular situation, there's a 50% chance that the baby will have type A blood and a 50% chance that the baby will therefore have type B blood. And so I'm going to go ahead and zoom in on the number 3 answer for this. And so here is the answer for number 3. And so go ahead and write that down. And again, what I'd like you guys to do is then on the back of the sheet, go ahead and finish it up. And so hopefully that helped, and I hope that you guys have a good rest of your day.